Um, good people, welcome to JJ Tech Tutoring. I'm going to be teaching you Laplace Transform, right? So if you haven't subscribed to the YouTube channel, you can subscribe, or you can subscribe at the end of the video, right? After seeing that you are able to understand how I teach and all, right? So I'm going to be taking you through Laplace transformation, right? So Laplace transformation is basically a very powerful mathematical tool applied in various areas of engineering and science. With the increase of complexity of engineering problems, Laplace transforms helps in solving complex problems with a very simple approach, a very simple approach, right? So for an example, as the name says, Laplace transform, that means it is then transforming the equation from another form to another form, right? For an example, it is then transforming this equation. Let me use t, because I was taught using t. It is then transforming f of t to f of s, right? So that means the equation that is placed in the input is in terms of t, and the equation that will be found, it will be in terms of s, right? Then this is the Laplace transformation, right? So the transformations happens here. The transformation happens here using what? The definite integration. Using the definite integration, right? To a new output function of f of s, right? That means then we are going to apply definite integration to f of t, and then we will then have the result of f of s, right? We will then have the result of f of s, right? Fair enough, right? For an example, what do we do and what do we use, right? This is the only approach. Let's say we want the Laplace transform of f of t, right? We want the Laplace transform of f of t. That means we are going to do what? Apply the definite integration to f of t, right? And have this st dt, right? St dt. So we're going to say integration of e to the power negative st multiplied by f of t, then we solve the problem, right? This is how we actually do it, right? For an example, let's say we want the Laplace transformation of 1, right? For now, here I'm going to use the theorem. I'm going to use the definition of integration to solve this problem. But as times goes by, you're going to be just using the table to solve problems, right? Now, let's say this one, as we have said, this one is f of t. We are going to find the Laplace transform of 1, right? So, integration of e to the power negative st multiplied by 1 dt, right? Then integration e negative st dt, right? Then what is the integration of e to the power negative st, right? And don't forget that here you have to put your intervals. You have to put your intervals here. You have to put your intervals. Right? Then we have to find the derivative of the exponent and divide by the answer of that. We have to find the derivative of the exponent and divide by that derivative, right? And the numerator should be the 1. Just put the numerator, divide by the derivative of negative st with respect to t is negative s, right? So we have integrated already. So it should be from infinity to 0, right? Infinity to 0. Right. Then e to the power negative st divided by negative s infinity minus e to the power negative st 0 negative t, right? So when we then put infinity to the exponent of anything, it will give us 0. Automatically it's error, right? So that means we cancel this out, it's 0, right? Then 0 minus e to the power negative st, or let us just put it once, to the power 0, right? To the power 0 divided by s, right? And there is negative here. So this negative and this negative will cancel. Then e to the power 0 will be 1. So that is the answer, right? Then I'm still going to do you examples now. So examples now, right? This does not make you an expert, right? Now, example number one. Example number one will be find the Laplace of f of t. F of t. I love x, man. Many people love x actually. All right, now 4 minus t, right? 4 minus t. Let us then find the Laplace transform of 4 minus t, right? So this basically this is just basics, guys. I'm still gonna teach you a lot of things. Now I'm just trying to get you used to that system, get you used to that Laplace transform, right? Now, then the solution. Find the Laplace transform of 4 minus t, right? So these things we can basically do them individually. We can find the Laplace transform of 4 and then find the Laplace transform of t. Clear, right? Then the Laplace transform of a constant number is just that number divided by s. And the Laplace transform of t, a number that is having an exponent. So that means it's that exponent divided by that exponent plus 1. I'm not sure if I'm making sense. I mean, when we want to do it in a shortcut, right? T, the Laplace transform of t, it should be that exponent. What is the exponent of t? It's 1 currently, right? Divided by s, right? What was the exponent of t? It was 1, then plus 1. So that means it's 1 over s squared, right? That is the exponent of t, and that is the Laplace transform of t, right? I'm not sure if I'm making sense, right? Now, the Laplace transform of 4 minus t, the Laplace transform of 4 minus t, it should be 4 over s minus 1 over s squared. Not sure if I'm making sense. If I'm not making sense, then wait, so I can do another example until you understand me, right? Until you understand me. Right. Now, let's do this again. Let's do this again. I'm telling you, I got proper marks in this thing. Right. Now, let's do the question again. Let's do the question again. So, because we have to understand. We have to understand. I have to write something that I can hear that even if you were teaching me without knowing anything, I was gonna grasp it. Now we're going to do it properly, right? Because I told you now that when you are finding the Laplace transform of t, right? You have to look at the exponent of t, right? What is the exponent of t? It's 1, right? That means we have to put it in the numerator. We have to put it in the numerator, right? That one, right? Divide by, what was the exponent of t? 1, right? So we have to say s1, right? Then we have to add what? 1. Adding 1, it's a rule, the moral, right? S squared, right? So this is the Laplace transform of t, right? Then let us find the Laplace transform of 4, right? The Laplace transform of 4 is just 4 divided by s. Why? Because the t that is beside 4 is having the exponent of 0. I don't know if you're making sense. 4 is having t that is to the exponent of 0. It's just that they were lazy to write it. They didn't write it, but it's there, right? So we would have said, okay, this one that is beside this, it will be 4 divided by t 0 plus 1. I mean s 0 plus 1. Then from there 4 over s, right? And then from there you say 4 over s minus 1 over s squared, right? I hope this is very clear, right? Now, if it's not clear, I don't know. If it's not clear, I don't know. Right? Now, let's do another example. Let's do another example. E to the power 2t plus t squared, right? Then let's find the Laplace transform of this. I hate doing something that is a little bit tougher because I don't deserve to do something tougher. The people who should do something tougher are the ones that are going to write the test. Those are the ones that practice with something tougher. As we are teaching you, we should teach you with something smaller. Don't come for me though. Let us do it. All right. So the Laplace transformation of this will be actually we can even do it with that other way, the long way, because already it's even e to the power 2t. I don't know. I don't have the table. When I don't have the table, what do I do? When you don't have the table, then you solve it. This is a practical example of do not lean on the table, because if you forget how it is solved, that means you're gonna be in trouble. I'm telling you, you will be in trouble. Then you have to know how to solve it, right? So that let us use the rule, right? But don't forget the table though. Don't be like me. I just forgot the table because I'm no longer doing math, right? Then you have to multiply by e to the power st. That is the rule, right? Don't forget the table, guys. Don't forget the table. Don't be like me. I forgot the table. Now let us solve it. 0. So we can just put this side and add 2t. We're taking the base and add the exponents, right? T. Then from there, 0. Then it's gonna be negative s minus 2 and t. I wrote the exponent without the base. Okay, right? Then from there, let us find the derivative of this, right? The derivative of the rest of this is just negative s negative 2 divided by this one, the original equation, which is e to the power negative s minus 2. And for the fact that I forgot the table, it makes you learn a lot, because I was starting to be lazy now to not want to explain these theorems for you, right? So you're gonna have this e to the power negative s negative 2t divided by negative s negative negative s negative 2, right? Now infinity and 0. Infinity makes it go away, right? Minus 0 will make it to be 1. Then from there, negative s minus 2, right? So we're saying this minus this, so this and this cancels, so it will be 1 over s minus 2. Hey, I should have known it most. But you see, when you know how to do it, you don't need to know the table, because you can just go and do it. You see. Now this is just another way of okay, this is the function and this is its Laplace transform. Like I said, the input, the output. The output should be in terms of s. The input should be in terms of t, right? I didn't forget the question. Don't come for me. We're going to solve that question for you, right? Because the question was like find the Laplace transform of e to the power 2t plus t squared, right? So how do we do it? This is the Laplace transform of e to the power 2t is 1 over s minus 2, right? Plus the Laplace transform of t squared. You tell me. You do this, because I just did the Laplace transform of t. What was the Laplace transform of t? Automatically, the Laplace transform of t was 1 divided by s to the power 2, because t was even the exponent of 1. Now the t is even the exponent of 2. Then what do? We take the exponent to the denominator. Yes, you are right. Then from there you say s. Then you wait. Then from there you have to take this exponent and add 1 from that exponent, right? So it's 2 plus 1, right? Then 1 over s minus 2 plus 2 over s to the power 3. Isn't not it? Isn't not it? This is correct, right? So that's it, right? Now, other things that I would like to do or to help you, or I will do it to the other video. I will do it to the other video whereby I'm helping with letting you know or solving for you those trick things, cosine, cos, and all, right? Because per table, we actually have to prove that we actually have to prove that sine 80 is equals to a divided by s squared plus a squared, right? Because at the University of Johannesburg, that's where I'm studying. At the University of Johannesburg, they actually want you to prove that table, right? So I'm just giving you a highlight of how the next session will be, right? Now, sine 80 is equals to a over s squared plus a squared, right? Cos 80 is equals to s is s squared plus a squared, right? All right, so that's it. So I'm gonna do some questions based on this, and also yes, I will do the questions based on this, and also I will help you then know how to derive them. I'm gonna leave a link whereby I was solving how to derive this, right? But then now that this is 2025, I want to do it again in 2025 with the skills that I've probably acquired for teaching skills, right? Now we can do just one question example, right? 2 sine 5t, right? Find the Laplace of 2 5 sine 5t, right? Then this is it. So that means our a is 5. A is 5, right? So the numerator is 5. So we can take this outside and solve this, right? So it's 5 over s squared plus 5 squared because it's a squared. Then from there, 2 5 over s squared. 5 squared is what? Is it 25? Is what? Yeah, it's 25, right? And from there, 2 multiplied by 5, it will be 10 over s squared plus 25. Right? That's it. Voila. Right. Now, what do we do now? What else do we do? We do the one for cos. We do the one for cos. What can we do for cos? Let me add a page and see what I can do. I can say 8 cos 2t, right? Then let us find the Laplace transform of that, right? So that means we're gonna say 8 psi t, and then we're gonna say s over s squared plus 2 squared, right? That will be 8 s over s squared plus 4, right? Then it will be 8s over s squared plus 4. That is it. That's it, right? That's it. So if you are using, let me just take you back. If you are solving this problem, because I see the others are now mad, this guy is now not teaching, is now expecting us to solve this from scratch because now he didn't tell us the easy way or the straightforward way to solve this e to the power 2t. No, in the table, e 2t under ft, right, is equals to, on fs, when you do the Laplace, it will be just 1 over S minus B, right? Right? So when you are given the equation like this, I mean not S minus B, man, S minus 2. So that means there in the table is S, B, T, that is gonna go to S minus B, right? So you're gonna just go and check the table. And some don't give you, some lecturers are not gonna give you the table. You're just gonna fight there in there.